The next area we need to address along our alignment here is the river crossing over here. So I'm going to zoom into that area in the profile model here. And then in the plan view, I'm also going to zoom out where we have the river crossing baseline geometry drawn. Now, the requirement here is we have to make sure, maintain that we have 25 feet above the water surface of the river. So we already have a piece of geometry in here for it represents the baseline of the river. It also has a vertical elevation on it that represents the water surface. So we're going to utilize this geometry to place an intersecting point onto our profile model here so that when we create our vertical curve, we can maintain that 25 feet above the water surface elevation of the river. Okay, so the first thing we need to do is actually figure out where this element crosses and intersects with the river road alignment. So again, we're going to go up and use our tool profile intersection point. So we're going to select that. In the plan view, we're going to select our river road center line, which intersects the baseline of our river. So we're going to select this as the intersecting element. It places the point there into the profile view. So that represents the elevation of the water surface for our river, of the baseline of the river here. Okay, so now we want to create a vertical curve so that we are 25 feet above that water surface elevation. Okay, so we're going to do that by utilizing Civil AccuDraw and placing a vertical curve between elements. Okay, so we're going to go back to toggle on Civil AccuDraw. So let's go back up to our general tools here, activate Civil AccuDraw. And if you recall previously, we used Civil AccuDraw to do an offset from the existing ground line. Well, now we're going to be utilizing Civil AccuDraw to do a difference elevation or a delta elevation from a particular element. Okay, so I'm going to go up to my parabola between points. We're going to select parabola between elements, and we're going to come down into my view here. So you got to make sure we click in the profile view so we get the vertical tools available to us in Civil AccuDraw. The one we want to use is this one here, the Delta Z. Okay, that'll give us the ability to place a vertical curve at a distance above this particular point here. So we're going to go up to the curves and we're going to go parabola between elements. And we're going to select our first element. So select this element over here to the left of the river. And then select this element over here to the right of the river. And then now in the heads up prompting, you can see we have station, we have DZ, and we have length. So first thing we want to do is we already have a point placed at the location that we want to do the 25 feet above, right? So we have that intersecting point there. We want to go 25 feet above that elevation. So what we're going to do is we're just going to go over to the station field here. So tab over to the station field, use a tab, and then just snap to this intersecting point in the profile view, just snap to there. And then in the DZ field, tab down to the DZ field, and then press O for the origin. And then again, snap to that point. And then you'll see the AccuDraw compass change to like a purple color. And then what we want to do is press the tab key again to the DZ field and key in 25 and press tab to lock in that value. And then now that's going to lock in that vertical curve to be 25 feet above that particular location. Now I unlocked the station there, so I'm going to use the tab key, go back in there and lock into that station. Don't want that to move. And then what we want to do is just data point to accept, and then it'll create the curve there. We want to make sure we trim both elements. I'm going to say trim both. And that's going to trim that up. So it creates that vertical curve and maintains that it's 25 feet above that particular elevation of the river point. Now we've created that vertical curve, let's check this real quick and make sure that we do indeed have the 25-foot clearance that we are going for. So what you can do to check that is you can just select the geometry here. So I'm just going to use my element selector, and if you zoom in, you can see it indeed lists a 25-foot distance there between the intersecting point and the actual profile element. So you can see indeed we do have that clearance of 25 feet that we are going for. One last thing I'd like to mention about this as well is that we are creating a rule and a relationship when we do this. So again, we snapped to that intersecting point. We created this 25-foot clearance there. So if that intersecting point were to change, then the vertical curve would also change. Okay, so it would always try to maintain that 25-foot clearance to that point. So just keep that in mind that there is a rule and relationship here and design intent. The design intent in this particular case is to be 25 feet above the elevation of the river or that intersecting point. So let's do a quick example of how the profile would change if we modified the elevation of this river crossing here. So I'm going to open up my river crossing here so we can see the profile view for that. So I'm going to open up a different profile model in a slightly different view here. Okay, so this is the profile of that particular geometry for the river. So you can see right now the elevation's at 7,300. Now if we were to change the elevation of this river element, say we would change it to say 7310, adjusting it 10 feet above from where it's currently at. You're going to notice down here in the river road profile it will adjust as well as the intersecting point. So let's take a look. So see how that works. So because there's a rule and relationship between the intersecting point and the vertical geometry that we created, we told it to always be 25 feet above. So when the point adjusts, the vertical curve geometry adjusts as well. So just wanted to point that out. So let's close this and we can continue on.